What is AI? ChatGPT is at the forefront of what people would consider AI. AI is a lot more. The world of AI is much, much more than a chatbot. You don't see Windows up here. You don't see CPU up here. Now, for the first time, AI is going to engage that $100 trillion economy. Let's talk about AI. What is AI? Most people would say that AI is a chatbot, and it's rightfully so. There's no question that ChatGPT is at the forefront of what people would consider AI. However, just as you see right now, these scientific supercomputers are not going to run chatbots. They're going to do basic science. Science, AI, the world of AI is much, much more than a chatbot. Of course, the chatbot is extremely important, and AGI is fundamentally critical. Deep computer science, incredible computing, great breakthroughs are still essential for AGI. But beyond that, AI is a lot more. AI is, in fact, I'm going to describe AI in a couple different ways. The first way you think about AI is that it has completely reinvented the computing stack. The way we used to do software was hand coding software running on CPUs. Today, AI is machine learning, training, data-intensive programming, if you will, trained and learned by AI that runs on a GPU. In order to make that happen, the entire computing stack has changed. Notice, you don't see Windows up here. You don't see CPU up here. You see a whole fundamentally different stack. Everything from the need for energy. And this is another area where our administration, President Trump, deserves enormous credit. His pro-energy initiative, his recognition that this industry needs energy to grow. It needs energy to advance, and we need energy to win. His recognition of that and putting the weight of the nation behind pro-energy growth completely changed the game. If this didn't happen, we could have been in a bad situation. And I want to thank President Trump for that. On top of energy are these GPUs. And these GPUs are built into infrastructure that I'll show you later. On top of this infrastructure, which consists of giant data centers like easily many times the size of this room, an enormous amount of energy, which then transforms the energy through this new machine called GPU supercomputers to generate numbers. These numbers are called tokens. The language, if you will, the computational unit, the vocabulary of artificial intelligence. You can tokenize almost anything. You can tokenize, of course, the English word. You can tokenize images. That's the reason why you're able to recognize images or generate images. Tokenize video, tokenize 3D structures. You could tokenize chemicals and proteins and genes. You could tokenize cells. Tokenize almost anything with structure, anything with information content. Once you could tokenize it, AI can learn that language and the meaning of it. Once it learns the meaning of that language, it can translate, it can respond just like you interact with ChatGPT, and it could generate just as ChatGPT can generate. So all of the fundamental things that you see ChatGPT do, all you have to do is imagine, what if it was a protein? What if it was a chemical? What if it was a 3D structure like a factory? What if it was a robot? And the token was understanding behavior and tokenizing motion and action. All of those concepts are basically the same, which is the reason why AI is making such extraordinary progress. And on top of these models are applications. Transformers is not a universal model. It's an incredibly effective model, but there's no one universal model. It's just that AI has universal impact. There are so many different types of models. In the last several years, we enjoyed the invention and went through the innovation breakthroughs of multimodality. There's so many different types of models. There's CNN models, convolutional neural network models. There's state space models. There are graph neural network models. multimodal models, of course, all the different tokenizations and token methods that I just described. You could have models that are spatial in its understanding, optimized for spatial awareness. You could have models that are optimized for long sequence, recognizing subtle information over a long period of time. There are so many different types of models. On top of these models, architectures, on top of these model architectures are applications. The software of the past, and this is a profound understanding, a profound observation of artificial intelligence, that the software industry of the past was about creating tools. Excel is a tool. Word is a tool. A web browser is a tool. The reason why I know these are tools is because you use them. The tools industry, just as screwdrivers and hammers, the tools industry is only so large. In the case of IT tools, they could be database tools. These IT tools is about $1 trillion or so. But AI is not a tool. AI is work. That is the profound difference. AI is, in fact, workers that can actually use tools. One of the things I'm really excited about is the work that Ervin's doing at Perplexity. Perplexity using web browsers to book vacations or do shopping. Basically, an AI using tools. Cursor is an AI, an agentic AI system that we use at Nvidia. Every single software engineer at Nvidia uses Cursor. It has improved our productivity tremendously. It's basically a partner for every one of our software engineers to generate code. And it uses a tool. And the tool it uses is called VS Code. So Cursor is an AI, agentic AI system that uses VS Code. Well, all of these different industries, whether it's chatbots or digital biology, where we have AI assistant researchers, or what is a robo-taxi? Inside a robo-taxi, of course, it's invisible, but obviously there's a AI chauffeur. That chauffeur is doing work, and the tool that it uses to do that work is the car. And so everything that we've made up until now, the whole world, everything that we've made up until now are tools for us to use. For the very first time, technology is now able to do work and help us be more productive. The list of opportunities go on, which is the reason why AI addresses the segment of the economy that IT has never addressed. IT is a few $1 trillion that sits underneath the tools of a $100 trillion global economy. Now, for the first time, AI is going to engage that $100 trillion economy and make it more productive, make it grow faster, make it larger. We have a severe shortage of labor. Having AI that augments labor is going to help us grow. Now, what's interesting about this from a technology industry perspective also is that in addition to the fact that AI is new technology that addresses new segments of the economy, AI in itself is also a new industry. This token, as I was explaining earlier, these numbers, after you tokenize all these different modalities of information, there's a factory that needs to produce these numbers. Unlike the computer industry and the chip industry of the past. Notice, if you look at the chip industry of the past, the chip industry represents about 5 to 10%, maybe less, 5% or so, of a multi-trillion dollar, few trillion dollar IT industry. And the reason for that is because it doesn't take that much computation to use Excel. It doesn't take that much computation to use browsers. It doesn't take that much computation to use Word. We do the computation. But in this new world, there needs to be a computer that understands context all the time. It can't pre-compute that. Because every time you use the computer for AI, every time you ask the AI to do something, the context is different. So it has to process all of that information. Environmental, for example, in the case of a self-driving car, it has to process the context of the car. Context processing. What is the instruction you're asking the AI to do. Then it's got to go and break down the problem step by step, reason about it, and come up with a plan and execute it. Every single one at that step requires enormous number of tokens to be generated, which is the reason why we need a new type of system, and I call it an AI factory. It's an AI factory for sure. It's unlike a data center of the past. It's an AI factory because this factory produces one thing. Unlike the data centers of the past that does everything, stores files for all of us, runs all kinds of different applications. You could use that data center like you can use your computer for all kinds of applications. You could use it to play a game one day. You could use it to browse the web. You could use it, to do your accounting. And so that is a computer of the past, a universal general purpose computer. The computer I'm talking about here is a factory. It runs basically one thing. It runs AI, and its purpose is designed to produce tokens that are as valuable as possible, meaning they have to be smart. And you want to produce these tokens at incredible rates because when you ask an AI for something, you would like it to respond. And notice, during peak hours, these AIs are now responding slower and slower because it's got a lot of work to do for a lot of people. And so you want it to produce valuable tokens at incredible rates, and you want it to produce it cost effectively. Every single word that I used are consistent with an AI factory, with a car factory, or any factory. It is absolutely a factory. And these factories never existed before. And inside these factories are mountains and mountains of chips. Which brings to today. What happened in the last couple of years? And in fact, what happened this last year? Something fairly profound happened this year, actually. If you look, in the beginning of the year, everybody has some attitude about AI. That attitude is generally, this is going to be big, it's going to be the future, and somehow, a few months ago, it kicked into turbocharge. And the reason for that is several things. The first is that we, in the last couple of years, have figured out how to make AI much, much smarter. Rather than just pre-training basically says, let's take all of the information that humans have ever created, let's give it to the AI to learn from. It's essentially memorization and generalization. It's not unlike going to school back when we were kids. The first stage of learning. Pre-training was never meant, just as preschool was never meant to be the end of education. Pre-training, preschool, was simply teaching you the basic skills of intelligence so that you can understand how to learn everything else. Without vocabulary, without understanding of language and how to communicate, how to think, it's impossible to learn everything else. The next is post-training. Post-training, after pre-training, is teaching you skills. Skills to solve problems, break down problems, reason about it, how to solve math problems, how to code, how to think about these problems step by step. Use first principle reasoning. And then after that is where computation really kicks in. As you know, for many of us, we went to school, and that's, in my case, decades ago. But ever since, I've learned more, thought about more, and the reason for that is because we're constantly grounding ourselves in new knowledge, we're constantly doing research, and we're constantly thinking. Thinking is really what intelligence is all about. And so now we have three fundamental technology skills. We have these three technologies, pre-training, which still requires enormous amount of computation. We now have post-training, which uses even more computation. And now thinking puts incredible amounts of computation load on the infrastructure because it's thinking on our behalf in the case of IT tools. So the amount of computation necessary for AI to think is about $1 trillion or so. It's really quite extraordinary. Now, I used to hear people say that inference is easy. NVIDIA should do training. NVIDIA's going to do, they're really good at this, so they're going to do training. That inference was easy. How could thinking be easy? Regurgitating memorized content is easy. Regurgitating the multiplication table is easy. Thinking is hard, which is the reason why